So let's talk about DevOps, what it is, why we should care. So these slides and what we're going to talk about are based largely on from this free book, DevOps for Digital Leaders, and the full references there. So just to set a bit of context, and in the book it paints a picture of Formula One, something we're all familiar with, Formula One, right? Maybe we've watched it, and we know these are cars that hurtle around, a few hundred miles an hour. They are the peak of engineering, right? But what you may or may not have noticed is that they have a lot of sensors in the car, right? Yeah. And they actually have little antennae, little radio sort of antennae that are sending data back to the pit crew, right? So all this like telemetry and real-time data. So in the context of like, we want the cars to go fast, right? So actually sometimes these little antennae won't actually help in terms of drag, and it would kind of almost get in the way. We've designed things to go really fast, but actually we've got these antennae. This real-time data, they use it to continuously improve performance, right? So, and if you've watched F1, you see the team in the gantry monitoring all the telemetry on the screens and seeing what's happening with the car, what's going well, what's going wrong. They could even anticipate issues that are happening if they start seeing some strange behavior. So what they can do with that is immediately translate it into change. So they can tell the driver to change the style of driving or come in for a tire switch or whatever. So this concept of real-time data that is enabling real-time adaptation and change. So it's a kind of a real-world analogy. Now bringing it into the tech world, technology and software, here's a statement really that sums up where we are today. Technology is no longer viewed as a supporting dependency. It's not just like an addition to business. It's rather, it's a primary element of conducting business, and it is a business. A lot of businesses now, even if they're not really a technology company per se, tech is intrinsically part of them as a business, right? So we have this conundrum, this trade-off seemingly between going faster, so faster software development, getting features out there quicker, and operational stability. So if we move too fast and we break stuff and things fall over, right? Ever since like the 1950s, when we had commercial computers kind of come onto the scene, there has been a demand for software and applications and solutions to problems, and we see that now with modern smartphones. We've got hundreds, thousands, millions of apps, and we want solutions to problems, or we want our life to be made easier by apps and software, both personally and in business. Now, historically, software was delivered off the shelf on CDs, DVDs, and when would you get an update? Well, you get an update when you bought the new version. You'd have software, you'd install it, and it would be like that, exactly the same for potentially years. But now with things like the proliferation of the internet, hyperconnectivity, virtualization and cloud computing support the ability to operate more quickly and roll out updates and even use software that's managed centrally and kept up to date. But IT, particularly in the enterprise world, it can be pretty slow and disconnected. So enter DevOps. So DevOps, dev plus ops. So when we talk about dev, we're talking about like the engineering, the development of software. And then in terms of ops is like IT management and deployment and maintenance and releasing software. So it's merging the two. So the idea is not to keep them separate, and historically they have been separate. So software teams, developers, have been kept separate from IT teams in terms of they're rolling out software and deploying things and doing all that kind of stuff. So the idea of DevOps is to bring them together. So rather than have these siloed separate teams, you have smaller, or we could well, we call them more agile teams because they're cross-functional or cross-disciplinary. They've got cross-functional expertise within a smaller team. They can both be developing, building, and also they're managing and refining the process used to actually deliver it, deploy it. And when we think about Agile, DevOps obviously has a relation to Agile because we're talking about smaller teams, they're cross-functional, cross-disciplinary, and they can own and deliver that whole sort of piece to deliver the end-to-end solution, building and deployment, and that's very powerful. So DevOps, this is from AWS, the website, how they frame it is that DevOps is the combination of cultural philosophies, practices, and tools that increases an organization's ability to deliver applications and services at high velocity. Okay, so it's involving it and improving products at a faster pace than we would traditionally in a traditional organizational structure. And, well, why do we want speed? Well, it means they can better serve their customers, get features, products out there quicker, and can be more competitive. So it gives them an edge, right? Here's a visual of the DevOps model. So you've got the company and you've got the customers. Your delivery pipeline is how you go from building, testing, and releasing as safely as possible so your customers can use it. But then you have a feedback loop, which involves monitoring and then planning and going back into that cycle. So that monitoring aspect is a bit like the telemetry that's collected from a Formula One car, all of those statistics and things. But that has to be designed. You have to design the systems to collect that data, to collect those metrics. It won't just happen in the same way that F1 cars are designed to send that data. So that's an important part of DevOps as well. It's not just an approach, kind of like project management approach. It's actually a fundamental engineering approach as well. So a quote from Gene Kim. So Gene Kim is the chap who co-authored the Phoenix Project, that book that's a novel, but set in like an IT kind of context and talking about DevOps. He wrote an article, and one of his quotes, which was adapted from a historical quote, is that enterprise DevOps adoption isn't mandatory, but neither is survival, right? So adopting DevOps in enterprise, you don't have to do it, but you probably won't survive if you don't, because the more enterprises that are adopting it and speeding up their delivery of value to the customer, they will have the edge over the old school companies who don't adopt that. DevOps supports Agile. So we're hopefully familiar with this.
Yeah.
We work in sprints to deliver iterations or increments of value. So we have the planning, the development sprints, user review, retros. There's that kind of continual cycle. And going into this cycle, you have, well, coming out of it, you have ideally, it could either be once at the end of every sprint, which might be 2 weeks, might be 4 weeks, you have deployment. And then you get, from it being in the production environment, you get operational feedback. And then you get, out of that, you get requirements. So if people are using this feature or they request other things, or if they're not using this or having problems, then that helps us go into the planning of what we then need. With continuous integration, continuous deployment, potentially you'll be deploying to the live production environment daily. Some teams deliver daily because they have such a well-tuned, fully tested deployment process, deployment pipeline. They can have a high degree of confidence that if their code has been reviewed by a colleague, signed off, all the automated tests have been reviewed, and they pass, then actually they're kind of pretty confident. They haven't introduced any regression issues. They do regression testing with their automated tests. They know that they can release with confidence. And that's what continuous integration, continuous deployment is. Not just releasing every couple of weeks. Potentially you can get to the phase where you're releasing daily, or even multiple times a day. That's what we're talking about. So it's that real time, almost real time adaptation and development.
Especially with the big companies nowadays, they, like you were saying, they obviously want to do things fast, effectively.
Yep.
I see a lot more companies using DevOps nowadays to, like you said, to fine tune stuff quicker to get it out in the development pipeline as well.
Yep. That's it. So some common benefits to this approach. So software updates are made in small, regular batches, allowing businesses to adapt quickly to new information. Mistakes or false assumptions are detected much earlier in the software development lifecycle, where they're much less costly to correct. So we're familiar with that benefit of agility, right, opposed to waterfall, where you're kind of committed for potentially 6, 12, 18 months, and then you only find out that it was a mistake at the end of the project. By detecting problems quickly and early, teams have much faster feedback and organizational knowledge improves, and teams can immediately apply learning and knowledge gained to improve the quality of application software. And yeah, by working in parallel across development and testing, agile teams can increase the velocity of application development and delivery. So it's all about speed, but quality as well. Some people argue, well, look, if you move fast, they kind of hear the phrase, move fast and break things, which is really like Facebook's approach, which has its place. But actually, the problem is that actually often the companies that are moving slow, they're moving slow because they don't have a proper testing, automated test coverage. They don't have a proper continuous integration environment. So it's actually a dual problem. Not only are they moving slow, but actually their processes aren't there to actually ensure quality. So not only are they slow, they're releasing code that actually is not very good as well. So actually by adopting this, being able to deliver things so quickly, you are investing in all these different processes and the mindset that makes it easier to deliver better quality code, which is the whole point. So some DevOps best practices, some of which we'll talk a little bit about. Again, this was from AWS, but continuous integration, continuous delivery. So that's what we've talked about. Continuous integration. So that's where we have our code versioned with Git, for example, and continuous integration means, let's say you've got a team of 5 developers and they're working on different issues. They can all be committing and pushing into the repo multiple times a day. But continuous integration will mean that the tests on the whole app are run, all the regression tests are run on the whole application every time a change is made. And that ensures quality. It ensures that any small change doesn't break anything else. That's continuous integration. So it means that you can, rather than developing something for 3 months and then trying to merge it into your main code base, you are continually integrating small features. Continuous delivery is about delivering to the end customer. So that's deploying, right? Deploying to the production environment. And if we have a good continuous integration process, we can often implement a good continuous delivery process. Microservices, another common kind of architectural style used within DevOps. So that's breaking up services into small, discrete, fully independent services that can talk to each other via APIs, rather than having a huge monolithic application. Infrastructure as code, we'll talk a little bit about that. That's where we can actually, we can version control not only our code, we know we can version control our database with things like database migrations, right? But we can version control our infrastructure. We can version control what servers we need, what power they need, and like what database service we need. We can actually codify all of that. And what that means is we can deploy our infrastructure in the cloud just by pressing a button, which is pretty cool. Monitoring and logging are key. Again, coming back to the F1, Formula 1 analogy, we have to build the tools or build into the system or into the F1 car the ability to send back data. And it's the same with applications. We need the ability to capture, monitor metrics, capture logs, capture errors, and be able to look at those in a meaningful way and be alerted about any serious issues that are happening so we can respond to them. And communication and collaboration, which is fundamentally part of Agile, right? So DevOps and Agile are best friends. So talking a little bit more about programmable infrastructure, or which is also known as infrastructure as code. So this allows teams to write code to manage configurations and automate infrastructure provisioning. Okay. So what that means is, let's say you're developing on AWS, and you have an architecture, you need like 2 web servers, you need a database server, you need to use the email sending solution, you need some S3 buckets to store your file, maybe a queuing system as well for scheduled tasks. All of those, you can go into like AWS admin dashboard and point and click and spin up your EC2s, choose what size you want them, how much RAM. Then you have to configure the firewall settings and make sure they can connect to the S3 buckets and the database server. You set up the database server. You can do all that manually, pointing and clicking through the AWS control panel in a browser. But AWS and other cloud providers also they are API first, so you can actually control all of the actions that you would do in the browser-based control panel through command line. But what we can do with infrastructure as code is use tools that integrate with that command line, the API, and effectively blueprint our architecture. And just by running our scripts, it will spin up all the services we need, and we've deployed our architecture basically one click. That has benefits because, again, it comes with speed. If we need to spin up the application again, we know all of the server requirements, the server specifications. There'll be no issues with like different versions of PHP or not enough RAM or the configuration of PHP. It doesn't have the modules installed because it's all nailed down and documented and bulletproof. So if you deploy again, you will get exactly the same environment. And that, again, removes risk. It makes it easier to deploy, quicker to deploy, and test. Cloud and platform as a service, also PaaS. So again, this is another area that's helped or enabled kind of DevOps and the ability to deliver things at speed. So on AWS, platform as a service is you don't worry about the underlying machines. You are just paying for the hosting platform. You just want to host an app, your app. So you want to chuck it at the cloud and just let it host it for you. You don't want to worry about what size of EC2 it is, how much RAM, how many CPUs. You just want it to do it for you. And AWS has some kind of services like Elastic Beanstalk, which is a kind of an easier way to access the cloud. You don't have to worry about the infrastructure underneath. You just upload your files and away it goes. And other ones like Heroku, Google App Engine as well. So these are stacks that can help in making development and testing quicker and more reliable. Containers, containerization. So a popular example we may have heard of is Docker. And then Amazon has its own kind of container-based kind of hosting solutions where you can deploy or provision infrastructure based on containerized or container specification. So containers or containerization is where you're not just shipping your code, you're actually shipping the environment. So you're shipping it's a way of shipping the whole runtime environment, including not just the application, but all its dependencies, libraries, configuration files, all bundled in one package. So it's almost like receiving a mini computer that you can then spin up, not sort of virtually. And by doing this, well, again, like we talked about infrastructure as code, containerization, you've documented everything and everything's specified and nailed down. There's no risk of having different versions of operating systems or different versions of PHP or .NET Core or whatever framework you're using. It's all specified exactly, and you can rely on that. It's a bit different from pure virtual machines because containerized apps can actually run a single operating system, but each container shares the operating system kernel with the other containers. So containers are effectively, they're more lightweight than a full virtual machine, right? So you can install a virtual machine of Linux on your Windows machine, for example, but it takes up quite a lot of resource. You can only really spin up one potentially and kind of use it. But Docker does it a bit more efficiently, but with the benefits of you being able to ship the kind of specification of the operating system and application. So containers, well, they're useful for local development, but they can also be run on the public cloud on AWS, so you can use it for deployment. And again, that means that if you're developing your app on a local container in Docker, you know that that will mimic the live environment exactly, because the live environment has been spun up from the same Docker image. Right. Cool. And then one final bit of terminology: Canary releases or dark launches. Oh, yeah. So this is like a release method where you're testing the performance behavior of a deployment or a feature in a kind of a phased way. So in a way that when we called the Canary, that's from the background of when they used to have canaries down the mines, because if there was a gas leak in a mine, the unfortunate little canary would be the one that passed out first, right, before it affected the humans. And so that's an early warning sign. This is the humans got to get out. If the canary's passed out, the humans need to get out. Yeah. And in a similar way, you're releasing a feature to, for example, a small number of users, and you monitor how it goes. If you start getting loads of error reports and like it's falling over, you roll it back, and you've only affected a small amount of users, and you gain that feedback, again, that telemetry, those metrics, and then once you're happy that it can be released wider, then you can roll it out incrementally. You'll know this if you use any social media platform, for example, if Twitter, Facebook, Instagram, whatever. New features, people get the new features at different times, right? So you might have friends that get a new feature, but you haven't got it yet. Yeah, well, what they're doing is it's these slow releases, because if they just rolled out a whole new feature, a big bang, to like 100 million users in one day, that's not the way to do it. You want to test it, you want to gradually release, and that's what's happening.